You're listening to The Cosmic Cast.
Well, excellent. Well, welcome everybody who's watching. So we did an initial welcome. Obviously, nobody saw that since we were still technically private. So this is a very special festive edition of the Cosmic Cast. I'm John Bunnyfisher. Of course, we've got the co-hosts of Marissa Lowe and Peter McArdle. How's it going once again?
Hello, once again, John. It's going good.
Yeah. Excellent, good. And so I would encourage anybody who's watching live right now to pop something in chat. We'll definitely take any questions about anything related to planetary science, or if you just want to drop in and say hello, that's also fine. But thanks to our Twitter followers, we've got a few pre-prepared questions that we can also have a bit of a chat about. And there's some really good questions actually in the bunch, so that's not too bad, is it really? And hopefully, quite possibly, Ricky Bahir might be joining us too at some point with luck, so we'll see how that goes. But yeah, there we go. Yeah,
that should be fun. I think you first mentioned this a good few months ago now, John, and we had no idea really how it works. I suppose we don't really know still how it works, but we're doing it now.
Yeah, well, I know that a lot of professional YouTubers use this to monetize stuff, and you can actually pay money to have some chats be higher in the scrolling mass of people watching. But I suspect I can see nice. We've got 6 viewers at the moment. So yeah, hello, and thank you for joining us this evening. I'm sure that's it's very kind of you.
Yeah, I mean, one of the things we always say is, we want to break down the barrier between like the general public and scientists, and I suppose this is definitely doing that. I don't think I've seen like hashtag Ask a Scientist on Twitter, but
they're not live streaming, are they? Yeah.
Yeah, exactly.
Yeah. Quite right. Okay then. Well, I guess maybe as people start to sort of join, maybe let's look at one of the questions that we've got through Twitter. So. I don't know, who should we start with? What do we reckon? What should we tackle first?
An easy one first. I don't know. A couple of people asked more than one, so I guess we'll alternate between people.
Yeah. Well, maybe should we start with Mary?
Yes. So thank you to Mary Owen, who actually asked this question on Twitter. And it was about rock samples. Hold on, let me just pull it up. Actually, John, did you write it down?
I did, yes. So Mary asked what happens to rock samples that are destroyed during analysis as a sort of part A, and a sort of a part B was what's with the weird block on the moon, which is also a very good question. Yeah, I mean, these are good questions, and so, I mean, in principle, we send things off for destructive analysis. Hello to Sam, who's just put something in chat. We'll be sure to get to your question in a second. But yeah, so what happens to samples that are destroyed? So obviously, destructive analysis is something we do a lot when we look at the chemistry of lunar rocks, and these kind of things are all noted, and nothing's really wasted when it comes to Apollo samples. They're all so precious. Yeah, I think it just gets put into a big block book somewhere, and every sample's noted what happens to everything, so you've got a full record of each sample.
Well, yeah, I was asking John about this before we started the stream, because I don't actually do any lab work as part of my PhD, but from what I know, certain types of analysis use like very, very small like laser beams, so
yeah,
not actually that much of the sample is affected at any one time.
Yeah, so I guess there's a big scale, isn't there, in terms of destructive? Yeah, so what you were talking about, these are like pits that are sub-micron scale, whereas for some methods, like argon dating, for instance, you'd effectively destroy milligrams of material, and I guess that's just stuff that's gone ultimately, isn't it? So I guess it all comes down to this sort of idea that we all, we apply to work on these lunar rocks, and we state our case that we want to do destructive analysis, and just like any other paper review or whatnot, a panel of people will look at that proposal and see whether it's worth sacrificing a chunk of the Apollo collection or not.
Yeah, and I suppose for context, like speaking to terrestrial scientists, like I know Elliot, he'll collect kilograms and kilograms of sample, and he'll be there, grinding it up and doing different types of analysis on it. That's not as much of a concern, maybe it's a bit of a faff for him to go back to Norway or whatever to get pieces of ophiolite, but I guess that's why there's such a complicated process for getting lunar samples, because there is that limited supply.
Yeah, exactly. You've got to make the most out of a very small amount of material, I suppose.
Yeah, like what, on the scale of, there's a few hundred kilograms of lunar rock, I think.
Yeah, so from the Apollo collection, there's about 400 kilos or so, I think. Yeah, so I mean, it sounds like a lot, but obviously it's still used very sparingly.
Yeah.
I think it's the same for meteorites too, I guess. It's still for meteorites that are held by NASA, you've got to go through a similar process, but obviously they're a bit more generous with what they hand out, because I guess in principle you can just go to eBay and buy a lot of stuff. So I guess Peter, we have to be tangling with some of these processes to get some of your samples.
Yeah, so we've just received news back that some of the samples I requested, we are being awarded them, but you could see in the feedback form that we were given, they really had, done their due diligence, and they said that they'd reviewed and they'd contacted people to check up on what we were proposing, essentially. So it wasn't a tick box exercise. They clearly had put a lot of effort into deciding whether or not it was justified, and fortunately it was in the case of what I applied for. Yeah.
Well, there we go. Well, I hope that answers your question, Mary. And of course, what's with the weird cube thing? I don't know if anyone watching saw this in the news, but I think it was one of the Chang'e missions identified some box-shaped looking thing on the lunar horizon, didn't they? But I mean, if you do Google it, Google like weird cube on the moon, and you'll see that this is like an incredibly pixelated image, and it's probably just a boulder that's very far away.
That happens to be quite cube shaped.
That happens to be quite, but again, I think that's probably just low resolution, as it's literally just pixels, I suspect.
Yeah, good point. If pixels are square and you've only got 2 of them.
Yeah, but it could be aliens. Can't rule that out. I mean, say never.
I've seen loads of weird ones about stuff on the moon. Yeah.
I mean, you've heard of Hollow Earth. Why not Hollow Moon? I mean, yeah. Anyway, so there we go, Mary, thank you. So maybe we'll take Sam's question in chat next. So thank you very much for writing in the chat here. So Sam, what are you asking now? Chang'e 5 mission returns samples to Earth yet? And how easy is international collaboration when it comes to analysing recently retrieved moon rocks? So yeah, it's a good question. So indeed, I mean, I guess we as the diligent viewers of this podcast, I'm sure will have seen, we were chatting to Josh Snape a few weeks ago about some of the first results from Chang'e 5. So yeah, they did indeed return samples back. It was back this time last year, wasn't it? It was in December it came back, and it's only now we're starting to see the first bits of published results.
Yeah, it's been very exciting. Like on all of the lunar science mailing lists, there's been so many new papers. I think analysis sort of started on them over the summer.
Yeah.
And now all the papers are being published on it.
Yeah. And then I guess to answer your question in terms of international collaboration, I mean, from the very beginning there were lots of international people involved. They were all the Chinese PIs who were spearheading the mission. They were all leading a lot of the sort of science projects, but definitely international collaboration was a big part of that. And it's only really recently now that they're putting out calls to sort of solicit other externally led projects, I guess, in a similar way to sort of NASA solicit invitations to work on Apollo samples and stuff like that. So I mean, yeah, I guess that's the thing, isn't it? Science is very international, isn't it? Which is no bad thing.
I did really like what Josh was saying a few weeks ago when we spoke to him, that they had someone basically in every time zone. Like definitely from like co-authors on a paper they're writing, they at least had someone on every continent, if not every time zone. So he said, when he went to sleep, he sent off the thing, emailed the next co-authors, and then by the time he woke up, there was more stuff to work on. So it sounds very intense, but also really fun. very good use of time.
Yeah, it does sound quite intense, doesn't it? But yeah, it must be very exciting. I'm quite jealous of being not of these guys being part of those first published data. It's quite cool, isn't it? Really.
Yeah.
Hannah, I see you've written a question in chat there. Hello, welcome. And Ellis as well. Look at that, young Ellis Bowyer is watching. And are there any countries that don't join in with collaborations, Ellis? Well, I'll just jump in ahead of Hannah's question. That's yeah, it's a bit of an awkward situation because, strictly speaking, Americans aren't technically allowed to work with the Chinese to the point where you can be investigated by the FBI if you're working with Apollo or NASA material and you have Chinese collaborators on your team. There's definitely been anecdotal stories of like senior professors' offices being raided by the FBI because they have like Chinese, they're collaborating with Chinese people. So while the scientific community still do collaborate with all the Chinese scientists, it's on an unofficial basis because they're not allowed to, which is, I don't know if China's got any similar reciprocal restrictions, and it's the same with the Russians as well. I think they tend to get a bit funny about, but you know, it's just politics at this point, isn't it? So I think the politicians do what they do, and all the scientists still do their best to get on with each other and get stuff done. Yeah, it's not good, is it? Well, there we go. So yeah, anyway, so Hannah, what are you saying here now? In terms of lunar basalts, are there any similar compositions seen in basalts on Earth, and if so, where? So yeah, again, that's another good question. So Hannah, yeah, so basically what we're looking at in terms of lunar basalts are, to get technical, are tholiites, and it's the kind of stuff that you see in Hawaii and Iceland. So they're basically the analogues. So basically, but they're more iron rich. That's the main difference, really. And so while obviously tholiites tend to be fairly iron rich, lunar basalts are even more so. And then in terms of composition, I guess what's quite unusual with the lunar basalts too is because obviously there's no atmosphere on the moon and it's highly reducing, because there's an excess of iron in these basalts in the first place, you get native iron crystallize out, and so you'll just get these, you know, lump. And there's no magnetite, for instance. Anything that would be magnetite on Earth would just be just lumps of iron, which is always strange to see, but also quite cool.
Sorry to interrupt, John. I believe we have someone else joining.
Indeed, which is going to modify our raid frames slightly. So not our raid frames, our frames. So I'm going to have to adjust OBS. And look at that, Mr. Ricky Bahir is joining.
Mahalo.
How are you? You're live on the internet. Please do not swear.
I will attempt not to.
So let me see. I need to do this on the
our
fly,
room
I
names also
suppose.
disappeared. I'm watching the stream on my phone as well, and yeah, we have half a Ricky head and half a Peter head, which is lovely.
That's pretty good, though. That's pretty good.
Actually, Peter, you're in the right side of your screen.
Okay,
So,
Do that.
yeah, stay on that side, and then Rick. Yeah.
Do
Oh wait, no,
that,
Rick.
and then I've got a text graphic pre-prepared. There we go.
Brilliant.
This is smooth.
Almost as if I knew you were going to join the call at some point.
And Peter, sorry, this is the first time we've actually met, so hello.
Hello, nice to meet you, Ricky.
And nice to meet you too. I imagine you've probably already given a synopsis to the audience, or have you had an episode actually where you've discussed what you do?
Yeah, this is good.
Yeah,
Yeah.
we had an episode last week or the week before. Yeah.
Great.
In fact,
great.
yeah.
Obviously, I knew that. But,
Yeah, exactly. So it's good. It's good to know that Ricky, you take such a keen interest in the podcast, of which you are a host.
Yes, and not just a host, a founding
member, no less.
Member, yeah.
Quite.
Yeah. And
Okay, well, we're just basically taking a few questions in chat at the moment, Ricky. There's so Vicky, hello, thanks for joining us. So Vicky, what are you asking here? So, the silly festive, Vicky, there are no such thing as silly questions, as I'm sure you know. But what rock, mineral, or fossil would you like to get from Santa this year? That's actually
Good question.
Definitely.
That's cute. Oh,
That's a good question. Well, I mean, probably not a fossil. I don't really like fossils, and Vicky, as I'm sure you know, I have a real aversion to things like tetrapods. I think the paleo reconstructions of them look really weird. Whenever I've seen a picture of a tetrapod, it's always just made me just want to just slap them back into the water from whence they came. And then you get the ammonites that are like not perfectly coiled, but like weirdly coiled, don't they? The ones that are like, and then they freak me out as well. There's something very unsettling about all of that. And like, just imagine seeing a trilobite scurry along. I mean,
John, I don't want to cut you off, but you're just listing the things that you don't want
yes,
at the
okay.
moment. After specifically saying I wouldn't want a fossil, you then went into a lot of detail about the fossils that you
I thought there'd be some
want.
comedic potential there, so I thought
it worked. It was good.
Yeah.
It was very good.
It's always chasing the comedy, you see.
Yeah.
But I don't know. Like, in terms of, it's a good, I don't know what, because I guess like I'm not sure a granite worktop would really count. Would that count in your mind,
granite worktop.
Because I'm sure you'd like a granite worktop as well.
I don't know.
So what I would like is a palisite meteorite worktop.
Ooh, actually, that is good. And Vicky, I think that would look great on our mantelpiece. Yeah.
Yeah.
Underlit as well, or backlit somehow to have the olivine.
Yeah. I mean, that's good. That is good. Yeah, I
not
like that.
Cheap either, not cheap, because I've looked into it before.
Yeah, they're not cheap. Yeah. And you've got to look after them too, as well. That's the pain as well, because otherwise they just sort of rust over time, don't they? Which is a real pain. You don't want to be polishing your meteorites every 5 minutes.
Is there enough palisite on Earth to make a counter from them?
Ooh.
Probably be a small one.
Yeah.
An island for it.
Yeah. I mean, Vicky didn't specify whether the quantity of material needs to actually be physically available.
Mm-hmm. Well, that's Santa magic down the chimney, isn't it? I suppose.
Exactly.
That's very much Santa's problem at this stage.
I would like. I have seen. Like TAS diagrams, so total alkali silica diagrams, where the spaces are like the different regions of the graph are different types of rock. So I've seen it where you get like a frame where on the graph it's actually that bit of rock.
Oh, that's cool. I like that.
So, like, super nerdy, but would really look good on a mantelpiece.
That's cool. Actually, I like that. There's probably a market there on Etsy, I'm sure.
It's probably with like less rare rock.
Yeah. That's good.
I would personally go for, because I'm a Martian researcher, I would go for samples from whatever Martian environment that has life within it, and I would have those, and I would just keep them and not let anyone analyze them.
You would be the overlord of Martian life.
Yes, yeah. And I would wait until they've attempted to do all of the, return sample stuff, taking it back, and then I'd be like, oh, guys, by the way, I already have it.
Yeah.
Like, I have a lot. And I just have it lying around as well.
So
we were talking about collaboration between like countries and stuff, and I really think you've embodied that with that. So thank you.
Yeah.
Ricky.
So I work at ESA, and they really promote collaborations.
Yeah.
And as I said, all the data I get, I just keep it for myself. That's
don't even publish it.
It's not publishable. It's not publishable data. Yeah. That's fine. Yeah.
No, that's good. That's good. It's a good answer. Good.
Thank you.
Shazali, hello, welcome to the stream. So let's see now. You've been reading up on some research on micrometeorites. Very good, especially from the ICL. I'll be honest, I'm not quite sure what that acronym means. Do you guys know? What sort of research is taking place in Manchester on this? I'm particularly interested in non-Antarctic samples.
Would ICL be Imperial College London?
Quite possibly. Yeah, so I mean, there's definitely a lot of micrometeorite research out there. I don't think we do much of it in Manchester ourselves.
No, I think the person who comes to mind is when we spoke to Martin Suttle.
Yeah, I think he does a bit of that, doesn't he? I mean, in principle, and I think, and there's plenty of other videos on YouTube that have done this, but I think a fun project that we could do, maybe, I don't know, is of course, I mean, in principle, these micrometeorites, they rain down everywhere equally, right? And so in theory, you can go to a rooftop and collect up some dust, and in principle a fraction of that should be micrometeorites, and that's something that various other YouTubers have done, but I think quite a fun thing to do. But the problem is, I think, is it gets quite difficult to sort of differentiate general detritus from meteorites, because I guess they're very small, aren't they? And I guess you get a lot of like Saharan dust particles and all sorts of stuff like that. So it's quite difficult to see what's blown Aeolian stuff versus glassy meteorite material.
But I think collecting things from rooftops is a legit way of getting hold of them. I remember, it was Martin Suttle from the Open University. He did a talk for Manchester a couple of years ago, and he said he was talking about, over this many years, this is the rate at which micrometeorites should hit a meter squared roof or something like that. So, would recommend looking up his papers if you want to find it.
Yeah, definitely. Yeah, recommend. Look at his papers and check your roof. You never know. Although maybe don't do that. Obviously, take very safe precautions when checking your roof. I wouldn't want any accidents now. Well, there we go. I hope that answers your question.
Yeah.
So there we go. It's good, isn't it?
So based on the megameteorite thing, so saying that you would, the Earth's surface is, I mean, it's not though, right? It's not consistently hit by the same amount of micrometeorites, regardless where you are on Earth. There must be some areas that preferentially get hit more than others. I'm assuming something to do with the shape of the Earth or something like that, because it's not perfectly spherical.
No, but I think it's still spherical enough that I don't think that makes any tangible difference.
So my basis was for studies looking at meteorite impacts on the moon, and that you get the preferential belt around the equator, where you get. Yeah.
It's a good point. I don't know.
Yeah.
So
I mean, it might statistically make a very little difference, but I don't know. But my question is because it's coming up to Christmas, and obviously it's going to be snowing, and a fun family activity is to stand outside with your mouth open and put your tongue out, and get snowflakes on your tongue.
Yeah.
Are you saying for other seasonal events where snow isn't going to be available, you could just stand outside with your tongue out and allow micrometeorites to cause impact gardening on your tongue? Is that what you're saying?
Right.
Well,
okay, I'll stand here. You go stand on the equator. Let me know how many you get, okay?
Yeah.
Well, we could take a before and after picture of our tongues and which one has been more eroded away by micrometeorites.
Maybe that
seems like some good science.
That'll be our next live stream. It'll just be you with your tongue out, maybe. Yeah, I think that'd be good content.
Yes. I think it's a good idea.
I think it's a good idea. Black Forest Bateau, hey, how's it going? Thanks for joining the stream. So, Vicky, you've got a follow-up question. Unlimited research funding. What would you choose to study? Well, that is a question, isn't it? I mean, I don't know. Just continue to just potter about the moon, I suppose.
Like, actually potter about? Do you want to go to the moon?
Oh, well, no, I mean, just, I don't want to go to the moon. No, just, I'll happily look at the rocks. Someone bring them to me, that's fine.
Okay.
I mean this in the kindest way possible, John. If I eventually got chosen to be an astronaut and I was given the opportunity to go to the moon, and I just saw you pottering around up there, that would just wouldn't make it worth it. I don't know why, I just wouldn't.
John, I love how it says unlimited funding.
Yeah.
And you're like, just carry on.
Yeah.
Carry on what I'm up to. It's not really the point of the question.
Yeah.
But okay.
Yeah, you'd still be a postdoc as well, wouldn't you? You'd still apply for postdocs. Try and renew your contract every 2 years.
Oh dear.
I have little imagination.
I would build a experimental analog volcano with gallons of analog magma and
analog magma. What do you mean by that?
Syrup. That's very vague.
I'd either use so you can mix up your real minerals and stuff like that, or you can use because magma's viscous, but also at certain temperatures it has other properties. It can be viscoelastic or shear thinning. So cornstarch with water, how that goes weird if you hit it or pour it in certain ways or shake it. Magma can do that as well. So there's polymer solutions that can do that. And I build a massive analog volcano and I don't know, try and shake the ground under it and see what effect that has, or see how gases move through it and how explosive eruptions are made. So it'd be huge. It'd be I'd need a few kilometers for this, but I mean, Vicky said unlimited money, so yeah. Is Vicky Santa? She's asking what rocks, minerals, fossils we want, and about unlimited funding.
It seems so. It seems so.
So I think I'm on to Santa this year. I'm gonna
How do you think a Santa would react if you sat down on their lap and you said, "I want unlimited funding for my research"? That's what you want.
I think they'd just be like, "Oh, how about this toy instead? Here you go."
I would take the toy.
Yeah.
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 Sorry, Peter. Did you have an idea what you want to do?
I'm thinking, yeah, I might. I would set up a research group which focused on bridging the gap between research using meteorites and into the early solar system and the formation of planets in our solar system, and bridge the gap with exoplanet and exo-solar system astronomy, and try and use all the great data that's been gathered there, and try and use Earth's more, or this solar system's more abundant data to help each other out and learn more about those other systems. I think. I don't feel particularly qualified to do that, which is why if I'm given the unlimited money up front, and I suppose that's not a concern, then I could just...
No, you've got room for mistakes and just keep on plugging the gaps with more money. That's the best way to do it.
That is the best way to do it. That's quite right.
Yeah.
Ricky, dare I ask what you would want to spend unlimited money on?
Well, so I don't know if you know this, but I started off my research actually looking at debris avalanches on the moon, and I think what I would do is quite similar to yours. I would try to do experiments on the scale that I'm used to analyzing them on, which is the size of the Kepler crater, for instance, on the moon. I would attempt to do that on Earth, though. So I would buy out kilometers worth of land and loads of material, and then just cause debris avalanches. I wouldn't record any of it. I would just do that. And then maybe after a few years, I'd start taking some measurements. And because obviously science isn't just about research, it's also about outreach and, giving back to communities. I would allow people to surf on the debris avalanches as they were occurring.
Would that be safe?
I don't know if it matters if it's safe or not.
Okay.
Because if anything happened, they can sue me, but I have unlimited money, so I can just pay them off.
Drown that in court. Yeah.
Exactly.
Oh, I thought you were gonna say if anyone got injured, you could help them out because you have unlimited money, but.
No.
Where would all your Martian life be with the samples that you have? Would you be threatened with debris avalanches?
This is going to come across very rude, John. Please don't take it in a rude way. But I specifically said lunar debris avalanches.
Lunar debris avalanches, okay.
Yeah. So if you could try and listen.
Okay, I'll do my best. Thank you, Ricky. That's good. Good.
Vicky says, sadly, I'm not Santa, but I could get you all some coal at least.
Oh, that's lovely.
Face.
Winky face.
Coal is always good. Actually, I found some coal thin sections. So I brought back, Mum brought this weekend a whole load of thin sections here, and I found. There you go. That's coal, I think, or is that charcoal, Vicky?
It's just an invisible thing. Oh, there we go.
Yeah.
Yep.
Oh, lovely.
Yeah. So can I ask, why did your mum have thin sections of coal?
Well, no, they were just at home, and I asked them to bring them back because there's a few bits I needed.
Oh, they're not your mum's
no,
thin
they're not.
sections.
My mum doesn't have a thin section.
Yes,
collection.
okay, they're your thin sections. Yes, yeah. That makes sense.
Microscope to look at them, John.
Well, in the office I do, not here, sadly. Yeah. Okay.
I would love to answer Daniel's questions.
Yes, I was going to say we should probably move to one of the Twitter questions. Did you want to read it, Amaris, or shall I?
Yeah, you go for it. I don't have it. I have notes here.
Okie doke. Well, so Daniel Wrench on Twitter, thank you very much if you're watching this, if you're there in the audience, or if you're watching this later on. So, did Earth also have a global magma ocean in its early history? If not, why not? And what CLIPS mission are you most looking forward to? So, I guess to tackle the magma ocean question first, would be to say that it probably did. I guess that's the working model, and so for those of you who are watching who may not be too familiar with a magma ocean concept, it's this idea specifically for the moon, at any rate, that the moon started off as a giant ball of magma in space that slowly crystallized, so all the ions sank to form a core. You then had crystallization of dense minerals like olivines and pyroxenes to form a mantle, and then plage crystallized and floated and formed a crust, right? So that's the general idea, that you have a massive massive body of magma that crystallizes. And so that's kind of the model that people have used to sort of extrapolate for all terrestrial planets in the inner solar system. And so we sort of think that everything had the magma ocean, and certainly we think that the Earth must have started off in a similar way. Whether it crystallized, so it's almost certainly that the mantle was formed as a result of olivine and pyroxene and things sinking to form a mantle. Whether what that first crust would have been, whether plage would have floated, or whether you've got something else going on, I guess we don't really know. I guess we can try and address that through modelling to some extent. Like, for instance, Mercury is compositionally really weird, and we know there's like a lot of sulfur and other bits and bobs there, and a lot of carbon, and so people have argued that maybe you get some weird carbon phases crystallizing to form some sort of sulfur-rich, carbon-rich primary crust. But yeah, I guess it's all a bit sort of speculative, because all this happened so long ago, and it's not a geological record we have access to on Earth anymore. I mean,
yeah, I guess with a lot of this, it's most of the useful elements to study are the ones that like partition, aren't they? Like the ones that say partition more into the core or into like mantle or into crust. You're looking for those sorts of ones. But again, like you said, John, we don't necessarily have very old material for the Earth.
Yeah, I guess we just don't really know. I mean, so I guess this is why the moon is so important to study in the first place, right? Because it preserves a geological record of a part of Earth that we don't have. We sort of use it as an early Earth analogue in some ways, I guess, to try and figure out the type of geological processes that might have been happening, on Earth during the Hadean at that point. Because I guess all this was happening, the moon's differentiation was happening at about 4.2, 4.3 billion years ago. And if you think about some of the oldest material on Earth, we've got fragments of zircons that are a similar age, and its magma ocean probably was a bit earlier than that even, so it's all a bit... but it's a good question.
And this was long before the introduction of the majority of Earth's water as well, wasn't it?
Yeah, exactly. It's exactly so, and when because obviously the moon is very water poor, so how that would have interacted a magma ocean on Earth, I guess, would have been quite wet probably, and it would have been receiving lots of impacts that are delivering water, and because ultimately I guess the oceans would have risen up from the mantle ultimately. I don't really know. I'm not too familiar with that particularly, but yeah.
It'll be interesting to see the Bepi-Colombo results for Mercury. You mentioned Mercury. I've heard that as well. That'll add some more information for us, and perhaps we'll be able to say a bit more about Mercury, if it had a magma ocean or not.
Yeah, absolutely. I mean, when's Bepi-Colombo due to arrive on Mercury? It must be a few years off still, I guess. Then he'd launched.
Yeah, it's a while off.
Yeah. Yeah, I guess Mercury is one of those planets we don't know too much about, really. There's not been that many missions that have gone there. Famously, very hard to go in towards the sun versus going out. But Daniel, I hope that sort of answers your question. And then, of course, the second part about the CLIPS mission. Now, I must admit, I don't know too much about the CLIPS missions. I think, just before we started recording, we were chatting a little bit about that.
Yeah, so for context, it's like the NASA missions. It stands for Commercial Lunar Payload Systems. So, like in the name, I think it is a bit more like different tech companies pay to have their instrument on board the missions. Yeah. And there were supposed to be several different like phases. So I think phase 1 was meant to be like 2 or 3 years ago. A lot of things have been delayed. The second phase was meant to be in 2019, and there's meant to be a third phase of instruments that go out. And they're all sort of oriented at in situ resource utilization. So using the regolith to build different things, assessing like I suppose the safety of the lunar surface. If humans were going back there in the long term, how safe or unsafe would it be for radiation and things like that? So all of the instruments on board of them, are geared towards making quite key measurements of some of these things. So yeah, I was thinking about this earlier, and I can't remember which Mars mission it is that has a heat probe on it. Maybe you'll remember, Ricky.
Insight, is it not? Is it not Insight?
Yeah, I remember.
Might have been Insight, yeah.
Yeah. I just remember before that launched thinking like, as someone who looks at like lunar volcanology and Martian volcanology a few years ago, just sort of constraining that and having some sort of idea of what heat flow is like in the lunar crust would be really useful. So I think in the second phase of the CLIPS missions, there's supposed to be a heat probe which goes, I think it's like 10 to 10 meters depth. And even just understanding that, you know, we always think of the moon and other bodies apart from Earth as being like a dead rock, being inactive, but actually making measurements of the temperature will be really useful for knowing if they are or not. We just assume, oh, well, they're cold now, it's been billions of years, but who knows if that's actually the case. So yeah, I just want to stick a stick into the lunar crust and go, oh yeah, it's cold, or oh yeah, it's warm. Yeah.
Well, I have higher expectations, Marissa. I looked at the list of CLIPS missions as well, and my favorite one was CLIPS 3, which actually was going to drill into the regolith and use a mass spectrometer to look at the cuttings from the drilling activity. I thought that sounded pretty cool. So that would be my favorite one.
Yeah, I've heard of like a few instruments that are similar to that do in situ like composition measurements. So I think there's going to be some instruments that do that on the Viper rover. I can't remember what Viper stands for, but I just think that would be really cool and also really efficient, rather than having missions, having samples brought back to Earth and then analysed by us humans. Having rovers that go around, point and shoot, and collect all that information for us is going to be amazing.
Yeah.
Do we expect the so if we were to drill into the surface of the moon, do we expect there to be compositional changes with depth other than anything that is irradiated by cosmic rays, for instance, or solar wind?
I guess it depends where you drill. So at least from the volcanology perspective, you could be drilling back through like different lava flows, and I mean getting slightly different compositions there, but still that would be quite useful for understanding like the chronology of eruptions and things like that. But I don't know if you were to drill other places if you would get drastically different things.
Yeah, I mean, in terms of the anorthostic crust, you probably would see some compositional variation. I guess, you know, you'd see a plagioclase that becomes more evolved, or less evolved the deeper you go, I suppose, in principle. And then, of course, well, I guess for a large chunk, you've got the mega regolith, haven't you? So,
of course, yeah.
You know, what's being introduced downwards and being mixed into it, I don't really know.
Yeah. Because the reason I ask is obviously because the moon isn't an active body in the same sense as Mars or Earth. Well, Mars used to be, and Earth, where you get sedimentary rocks forming, for instance, because of water flows or aeolian activity. So obviously we have the mare, which are compositionally distinct from the highlands, and that's obviously differences because of their origin. So yeah, I just wondered whether we'd expect any differences. That's interesting. Yeah. With the in terms of this area of resource utilization, obviously within the past 10 years or so, we've realized there is actually quite a lot of water on the moon in terms of water ice. So in these permanently shadowed regions, mostly around the polar regions, specifically, I think there's more in the South Pole. And I think the estimates from LRO and from the Chicharana, I'm going to mispronounce it because I can't remember exactly what it is. It was the Indian Space organizations. Yes. Yep. Can you repeat that? Sorry, what was it called?
Chandrayaan?
Chandrayaan, yeah. Chandrayaan 1, yes. I know number 2 is now orbiting. but from one, I think sent in 2008 and it stopped working in 2009. They measured something like around about 600 billion tons.
It was the M cube data set.
Not tons, kilograms, sorry. Yes, M cube data set.
Although a lot of that, I think, was locked in the regolith, wasn't it?
No, only small amount of it was locked in the regolith.
Okay.
Yes, yeah. So they estimated a lower limit of 600 million kilograms. Sorry, so it's 1 billion kilograms of water ice in the poles. So that's outside of anywhere else. So just the polar regions. So above 60 degrees south or north. And that's obviously something that a lot of people are looking in for. Well, I say people, industries are interested in mining. So my question is,
here we go.
Yeah, so my question isn't necessarily related to the mining aspect of it, but it is if the moon had water on it introduced in the same way as Earth did from comets and wet asteroids bombarding its surface, would we expect there to be any aqueously altered minerals on the moon from impacts, for instance, causing melting of any ice that was there, or do you think it would just disappear too quickly?
So, yes, I see what you're asking. Basically, what you're saying is that there is ice packs in permanently shadowed craters, so therefore would that be aqueously altering the rock that's underneath it? Is that what you're asking?
Well, maybe more so when the water was first introduced to the moon, before it then only could lie within these permanently shadowed regions.
Well, but I think it was, so I think a lot of that water isn't necessarily indigenous water. It's stuff that's been captured over time, I guess. So you get a lot of solar wind contribution to it, and you get a lot of passing comets and stuff. So it's not quite the same as how the Earth got its water, for instance. So I mean, so there's never been any flowing water on the moon, which I guess would be a requirement. I mean, on a very localized area, I guess these areas have never seen daylight. So yeah. I mean, I think that basically, I think that the pressure regime is such that any ice would sublimate straight away.
Yes,
so
that's what I thought.
You'd never get any water, basically.
Yes, yeah.
You can test that in your massive debris flow simulator.
Just put
We can also get some impacts going.
Put the whole thing in a vacuum chamber.
Yeah. I was planning to do that anyway. Yeah. So when the people are surfing on it,
in the vacuum,
yeah, they're going to be in a vacuum as well,
which
good. I'm sure will be fine.
Definitely fine.
Yeah, exactly.
Yep. Cool. Well, look, we've got one final question that we need to tackle before we should probably sign off, unless, of course, there are any ad hoc questions that pop up in chat, and it's good to see there's still 11 to 13 of you or so that are still watching, so I hope you're enjoying the live stream so far. Do let us know if you think it's awful, if you think it's brilliant in the comments. But finally, Mum has the question, and Perne, hello, I hope you're watching, has a question of how important are the moons of Mars, and can we compare them geologically with our own moons? So I think that's a good question. I mean, I guess, how much do you know about Martian moons, Ricky?
I know a small amount about Martian moons.
I guess the important thing to say is that they're very different to the terrestrial moon in the sense that, I guess, we think they're captured asteroids, don't we? We think they're sort of chondritic, potentially.
Potentially. So there's two prominent lines of thought. Is that a saying? Lines of thought? I feel like that's two sayings that I pushed together.
Thought, line of evidence.
Two
schools
theories. There's two schools of theorems that people currently have, and they are either captured asteroids, or they are from a giant impact on the moon, and then
on Mars, you mean?
Basically leftovers from a debris disk that will have formed as a consequence of a giant impact.
Don't we have spectral data for some of these moons though, that point to the more chondritic?
We have very, very low resolution spectral data for them, and they do line up spectrally with what you would expect for the composition of a carbonaceous asteroid. Is that what you would call it?
Mm-hmm.
basically. So the spectrum lines up with what you would expect for asteroids. Yeah. So that's the argument for them being asteroids, essentially. The issue is modeling of the capture process that would happen for them to get into their place in orbit is very, very difficult to simulate. So the idea that the Mars would have captured some asteroids and they would lie at this point in the orbit is quite implausible according to modeling. So the second theory goes that there was a giant impact event in the past on Mars that potentially formed the northern lowlands, or a series of impacts that caused the northern lowlands. So for anyone who doesn't know, Mars is split up topographically. So in terms of its elevation, in the southern highlands where you have all these highlands, and then the north is suddenly this flat, very low elevation area, and we call them the northern lowlands because of that reason. And it's thought that potentially a few impacts, maybe 3, or one giant impact, caused this lowlands to occur very early on in the past of Mars, around about 4.2 billion years ago. And that will have released a huge amount of material. And it's thought that that material would have released and caused almost a proto-disk, so a disk like we see around Saturn, essentially, around or like we would have seen around Earth when the moon was forming. But as that disk lost energy, a lot of those new asteroids, I guess, that were floating around in this disk, they will have fallen to the surface, and that lines up with where people see low angle impacts on the Mars. So it lines up with where one would expect that disk to form in modeling, and we do see those high angle impacts, craters.
Presumably there would have been quite a lot of material raining down. So wouldn't you expect a peak of impacts at a particular age at very
Yes. So I can't talk about it in detail because it's not published work yet, but I know that there is a certain time period we see them in, and it's slightly complicated because we expect around that time Mars had more of an atmosphere as well. So some of that material that would have been raining down, it won't match up with what we'd expect the size distribution to be, because as it's interacting with an atmosphere, it breaks up and it breaks down this material. So that's just an added complication, but there is evidence that potentially happened. And the idea is that Deimos and Phobos are leftover material from that impact event.
Well, I guess we'll find out soon enough, won't we? As the Japanese Space Agency, I think, are sending a lander. I forget the name of the mission off the top of my head, though.
Russian Moons Explorer.
There we go. Indeed.
Yes. So yeah, I guess very different to the Earth-Moon system, but still very interesting.
Well, potentially impact related though.
But either way, very different. Well, I guess if it's impact related, that would be similar to our own moon. But I guess they're much smaller than our moon, aren't they? I guess that's the critical thing.
Significantly,
so
yes.
The geological processes involved in terms of forming our moon would have been very different to those two. I guess they would have cooled incredibly rapidly if they were just because I guess presumably the impact would have melted material as well, wouldn't it?
Yes. Yeah.
Well, there we go. So, Vicky, thank you very much. Thank you that you enjoyed the live stream. Do we have any plans to do any more live streams? Well, I mean, that's all down to you, the audience. If you would like to see more live streams, we could definitely accommodate more in the future. It's certainly been a lot of fun. Seeing all you online, answering your questions. It's been good. I don't know if you can do a big thumbs up on live streams, but if you can, then do give us a
I mean, you can just do this.
No, not us, Marissa.
Oh.
No,
also, Marissa,
asking the questions. Oh.
Your thumb just looks so strange there.
Wow. That's not quite the ending that we had in mind, maybe.
I think it's a perspective thing. Like if I go like this, you know.
Oh dear. Well, I think that's time to sign off then, isn't it?
Indeed. When the thumb-based banter comes out, it's time to call it a night.
Hey, that's the only material I had for this whole thing.
Is that what you prepped for all afternoon?
Just waiting for someone to put their thumb up.
Just like hours of like jokes surrounding that topic, just wasted.
Yeah.
Shocking. Well, maybe you can tweet about it. Listen, thank you all very much for watching in the audience. I hope you've enjoyed it. Seriously, it's been good fun. And you know, I think really all that's left for us to say from the Cosmic Cast is to wish you all a very happy holiday season.
Yes.
Bye.
Happy holidays, everyone, and
What do we normally say?
thank you for
at the end
tuning in.
Oh yeah, social media links everywhere.
Yes.
Bye.
Yeah. Thanks for asking questions. Whoever asked questions.